Hello everyone, my name is Priyanka Yadav. I'm finally a student of Civil Engineering in University of Lucknow and I'm going to present a seminar presentation on topic Bandra Worli project. So, moving forward, these are the table of contents that I'm going to discuss in detail. Introduction, features, design, main components, project benefits, additional features and facts. Now, so let's begin with the introduction. The Bandra Worli Sea Link, officially named Rajiv Gandhi Sea Link, is a cable stayed bridge with pre-stressed concrete steel viaducts on either side that links Bandra in the western suburbs of Mumbai with Worli in the southern Mumbai. The Sea Link, which is constructed by Hindustan Construction Company India, which is among the most complex and advanced construction project ever in India. It is inaugurated at 30th June 2009. The first 4 or the 8 lanes of the bridge were opened to the public on 30 June 2009. All 8 lanes were opened on 24 March 2010. Features: carries 8 lanes of traffic with 2 lanes for buses. Location is Mumbai, Maharashtra, India. Total length 5.6 km, that is 3.8 km over the sea. Width 2 into 20 meter. Height 126 meter, longest span 2 into 250 meters. Design: BWSL was designed as the first cable stayed bridge to be constructed in open seas in India. Due to the overlying geology, the pylons have a complex geometry and the main span over the Bandra Channel is one of the longest span of concrete deck attempted. Balancing these engineering complexities with the statics of the bridge presented significant challenges for the project. The substructure of the viaducts were the heaviest precast segments to be built in India. They were built using span-by-span method, using overhead gantry through a series of vertical and horizontal curves. Main components: pylon tower, stay cables, roadway, piers, foundation. The 20,000-ton Bandra end span of the bridge deck is supported by stay cables within a very close tolerance of deviation in plan and elevation. The BWSL is the first infrastructure project in Mumbai to use seismic arresters. Seismic arresters will enable the sea link to withstand earthquakes measuring up to 8.0 on Richter scale. Foundation: the construction of the bridge structure presented major engineering challenges. These included the highly variable geotechnical conditions due to the underlying marine geology of the seabed. The foundations for cable-stayed pylon towers consist of 120 reinforced concrete piles of 2 meter diameter. Those for the viaduct piers consist of 484 piles of 1.5 meters diameter. These 1,604 piles were driven between 6 meter and 34 meter into the substrate in geotechnical conditions that varied from highly weathered volcanic material to massive high-strength rocks. Pylon tower. BWSL largest pylon tower are 128 meter high. The largest pylons for the bridge concrete tower with continuously varying cross section along the height of the tower. Precast yard. The precast yard was located on reclaimed land. The yard catered to casting, storing and handling of 2,342 concrete steel precast segments of the project. The storage capacity requirement of yard was about 470 precast segments. As the area available was limited, the segments were stored in stacks of up to 3 layers. Now, let's discuss the structure. BWSL consists of twin continuous concrete box girder bridge section for traffic in each direction. Each bridge section, except at the cable stayed portion, is supported on piers typically spaced 50 meter apart. The bridge consists of the 3 distinct parts: the north end viaduct, the central cable stayed spans, and the south end viaduct. Both the viaducts used precast segmental construction. The cable-stayed bridge on the Bandra Channel has a 50 meter, 250 meter, 250 meter, 50 meter span arrangement. On the Worli Channel, it has a 50 meter, 50 meter, 150 meter, 150 meter, 50 meter, 50 meter span arrangement. northern and southern viaducts. The viaducts on either side of the central cable-stayed spans are arranged in 300-meter units consisting of 6 continuous spans of 50 meters each. Expansion joints are provided at each end of the units. The viaducts were built utilizing precast, post-tensioned, segmental, concrete steel box girder sections. An overwhelmed gantry crane with self-launching capability was custom built on the site to lay the superstructure of the precast segment. The precast segments are joined together using high-strength epoxy glue with normal pre-stressing initially. The end segments adjacent to the pair are short segments, cast in pseudo joints. Geometrical adjustments of the span are made before primary continuous tendons are stressed. Cable stayed spans. The cable stayed portion of the Bandra channel is 600 meter in length between the expansion joints. A center tower with an overall height of 128 meter above pile cap level supports the superstructure by means of 4 planes of cable stay. Cable spacing as 6 meter along the bridge deck. A total of 264 cable stays are used at Bandra Channel with cable lengths varying from approximately 85 meter to nearly 250 meters. The cable stayed portion of the Worli Channel is 350 meter in length between expansion joints. A center tower with an overall height of 55 meter above pike cap level supports the superstructure by means of 4 planes of cable stay. Cable spacing is 600 meter along the bridge deck. A total of 160 cable stays are used as Bandra Channel with cable lengths varying from approximately 30 meters to nearly 80 meters. Now let's discuss the project benefits. Saving in vehicle operating cost to the tune of rupees 100 crores per annum due to reduction in rush in the existing roads and lower vehicle operating cost on her bridge. Considerable savings in travel time due to increased speed and reduced delays at intersections at existing roads. The sea link reduces travel time between Bandra and Worli during peak hours from 60 to 90 minutes to 30 to 20 minutes. Easy in driving with reduced mental tension and overall improvement in the quality of life. Improvement in environment, especially of reduction in carbon monoxide, oxides of nitrogen, and reduction in noise pollution in areas of Mahim, Dadar, Prabhadevi, and Worli. Project to have no adverse effects on fisheries, marine life, and livelihood of fishermen. Reduced accidents,